Okay, here's our video today on rationalizing denominators, Algebra 1 regions. So let's look at an example here. So when we rationalize denominators, we're actually going to look at radicals, right? So let's get the pen going here. Radicals. Radicals. Well, what is going on with my pen today? Let's do that over. Fix that there. Write it again. Radicals. All right, so radicals, radicals have that radical sign. That's the radical sign. So in middle school, you may have heard the square root sign, right? The square root, for example, square root of 36, is 6, right? So that's what radicals are. So if we see a fraction, let's say we had 2 over the square root of, let's say, 3. So see, the denominator has a radical sign. We do not want that. We do not want a radical. Don't want a radical in the denominator. There we go. Now, we don't mind if there's a radical in the numerator, but not in the denominator. All right, so give you a second to read that again. All right, there's a big star, right? We do not want a radical in the denominator, so we're going to rationalize it. That's all we're doing. We're going to rationalize it. All right, let me clear this out. In 1, in 2. All right, so dealing with radicals, let's put that question back up. We have 2 and the square root of 3. And all we have to do here is just multiply by the denominator on the top and on the bottom. So we have in the numerator, we have a square root of 3 and the denominator, a square root of 3. And then just multiply like you would do fractions, right? So this would be 2 times the square root of 3, which is 2 square root of 3, right? Remember, don't do this. It's not, put it over here. It's not this, not that. No. Just make sure you make that number a little bigger. It's this, like that. And this is going to be over 3. Why do you think it's 3? What do you think? Well, the square root of 3 times the square root of 3 is what? The square root of 9. And what's the square root of 9? 3. There we go. So we just rationalized the say that 3 times. We just rationalized the oh man, I cannot say it today. The denominator. There we go. We rationalize the denominator. Let's do a few other problems. Clear that out. See if you can do this on your own. What if I gave you, let's do another one. What if I had 3 square root of 2 over 2 square root of 3? What do we do now? What do you think? All right, pause that for you. Try to see if you can solve it. Now, when you're doing something like this, do not include, when you multiply, do not include the coefficient. So that 2 is a coefficient. If you remember, like if you had 2x, the x is the variable, the 2 is the coefficient. So let me write it over here. Do not include the coefficient. Right, write that over here. The coefficient. And there we go, the coefficient. Do not include the coefficient. So that's the 2. So what I want to do here, let's get rid of that equal. Let's just write it again. Do green. We have 3 square root of 2 over 2 square root of 3. So all we're going to times is the square root of 3. And what do you think we get? What do you think our answer is now? So over here you have 3 square root of 2 times the square root of 3. Right? So that's going to be 3 square root of 6. Right? And on the bottom, what do you think the bottom will be? It'll be 2 square root of 9. Right? So let's keep going. So we'll use another pen, another color. Bring an arrow, so see what we're doing here from this, right? So 3 square root of, so now we have 3 square root of 6 divided by, and we're going to have 2 square root of 9, which is just 6, right? Because the square root of 9 is 3. 3 times 2 is 6. And we can go further. What do you think we can do? Well, the 3 and the 6, wait, we can cancel that out, right? 3 goes in the 3 once, 3 goes in the 6 twice. So we're going to be left with the square root of 6 over 2. Just like that. All right, let's do another problem. All right, clear that out. Rewind if you need to. What if we had, I'll change the color again. What if we had 10 square root of 5? Sorry, pause the tape. What would you do? If you want to pause the tape. All right, so again, we want to do the square root of 5 in the numerator and the denominator. And over here, we're going to have 10 square root of 5. And what do you think the denominator is? In the numerator, we have 10 square root of 5. Square root of 5 times the square root of 5 is the square root of 25. But the square root of 25 is 5. So we're going to have 10 square root of 5 over 5. But we're not done. Remember, we want to have it in simplest terms. So what would this be? Well, 5 goes in the 5 once, 5 goes in the 10 twice, so the final answer, we'll use purple, it'll be 2 square root of 5 over 1, which is just 2 square root of 5. There we go. How about one more problem? Why not? Okay, let's clear that out. All right, what if I had, let's say, which is a good one? Well, we'll do, let's say, 7 square root of 3 over, let's say, 2 square root of 7. Try that one. What would you get? All right, so I'll use that color. Why not? We haven't used that yet. So again, we're going to, we do not use the coefficient. So we're going to do multiply on top by square root of 7 and the bottom by square root of 7. And now we're going to get 7 square root of 21. And over here, what will we have? What do you think? So we have 2 square root of 49. 7, right? And we'll move it over here. So we have 7 square root of 21 over square root of 49 is 7, and 7 times 2 is 14. So what's our final answer using blue? So 7 goes in the 7 once, 7 goes in the 14 twice. So we're going to just have the square root of 21 on top there. There is a 1 there, but you don't have to put the 1. Well, if you want to, why not? Put the 1 there. You don't have to put a 1 there. And then this will be 2. Or you could just say square root of 21 over 2. All right. So in the next video, we're going to do a little more complicated ones. See how I said that? Complicated ones. And we'll do some where we have to add. So that'll be in the next video. All right. Great job.